Hi everyone, welcome to Vishwablooms. So in this video, we'll be looking at optics, class 8, physics, concept 6, explanation. So let's get into the video. So this concept is completely about sign convention. Okay. So before learning what is sign convention, what are the prerequisites? Let's see that. So what are required, the necessary knowledge that is required for learning this chapter, we have to see. Okay. See. First and foremost thing, you should know what is pole, you should know what is focal length, and you should know what is the image distance. You should know the object distance. Yeah, these are all something which is very much necessary. You should also know the image height and object height. These are something you should know. Okay, now we will see where they are actually. So let's see how to measure them and where they are located in the particular mirror. So first I am taking the concave mirror, and to the other side I am taking a convex mirror. Okay, now I am drawing the principal axis. You all know this line is principal axis. So that is clear. So I am erasing that because I need to draw there. Okay, now see, this is the focus, this is the center of curvature. For this is the focus and this is the center of curvature, right? Now you all know that the object must be kept in front of the mirror where it is a reflecting surface, right? So now from this is pole, P, pole. Okay, now first three things we have seen, right? So what were the three things I have told? Pole, focus, center of curvature. But I told focal length. I'll tell you, no need to worry. The distance from the pole to the focus is called as focal length. That is discussed, I think. So we have discussed that also. So that will be represented by small f. Focus will be represented by capital F. Okay, that is clear. Again, now we have to see something called radius of curvature, that is capital R. So the distance from pole to the center of curvature is radius of curvature. Similarly here also, from the pole to the center of curvature is radius, and from the pole to focus is focal length. Clear? So these should be clear by now, and let's move on to the next thing which we have to see. We have to see something called image distance and object distance, I have told. So how do we measure them? Now for example, if I have kept the object here and here I have kept the object here, the distance from the pole to the object is called as object distance. I repeat it again. The distance from the pole to the object is called as object distance. Similarly, here also from the pole to the object it is called as object distance. So I hope this is clear to you. Okay, now we have seen object distance. So object distance is represented by small u. Okay, so it is represented by small u, letter u. Okay, now let's see something called image distance. Okay, now say we all know, right, how this it will form images. We have seen in the ray diagrams as well. So here it will form between P and F. Okay, for this particular convex length between P and F, and it is going to be a diminished image. We know this because we have studied the ray diagrams previously. Now the distance from the pole to the image, wherever the image is formed, that distance is called as image distance. Okay, now similarly, if I see in this concave mirror, it's placed between F and C, so how it is going to be enlarged image, right? An enlarged image. So the image is going to form beyond C, but it is going to be very big image. So that distance from the pole to that distance is called as image distance, and it is represented by the letter small v. Small v. Okay, small v. Clear? Okay, now what and all we have studied, u and v also we have studied. So just keep it aside. Whatever we have studied, I am just writing to one side. Okay, now that is also clear to you. Okay, fine. Let me just remove all these, and yeah, so u and v also we have studied. Okay, that is clear, right? So these are all some things you should keep in mind. Now I told you object height and object image also in the last. See, now I told that image is formed here for this and image is formed here for this. See, the height of this object is called as object height. Height of this object is object height. So for this is the height, and for this is the height. That is clear to you? Okay. Now height of the image is called as image height. That's all. Very simple, right? These two are. So object height is represented by small letter h, and image height is represented by h dash. Okay, h dash. So what and all we have studied, let's just recall it one last time, and then we'll move on to today's topic. Okay, so h dash also we have seen. So these are all the topics which we have seen just now. First is pole, we have seen focal length, center of curvature, radius of curvature. We have seen image, object distance, image distance, height of object and height of image. So these are all something which we have learned, and these are the prerequisites for the concept. Okay, that is clear to you? Fine. Now let's come into the rules of sign convention. Now, but before that, you have one more prerequisite which is not related to physics, but it is related to mathematics. Okay. So one thing you should all be knowing is Cartesian plane. I hope you all know what is a Cartesian plane. I'll just draw. If you don't know, you can just see it. Not rules here, okay? Not talking about the rules. I'm talking about Cartesian plane. So in mathematics, you could have studied about Cartesian plane. So there are two axes. You all know, x-axis, y-axis. So this is x-axis, x dash axis, y-axis, y dash axis. Okay. So you all know the values moving towards up of the, moving along y-axis is positive, moving along y dash axis is negative, and values moving along x-axis is positive and moving along x dash is negative. You all know this, so I need not repeat it again. Fine. Now, here why are we talking about Cartesian plane? Let's see that. See, first the image, the mirror, whatever is there, either it is a mirror, either it is a concave mirror or a convex mirror, whatever it is. Okay, everything must be placed in this way. In the x and xy axis, it has to be placed. So how it is going to be placed? Let's see that. Okay. So I am going to just remove off the x axis and xy axis. X dash, sorry, y and y dash I am removing it, and x and x dash are here. In the place of y and y dash axis, we are going to place the mirror. Suppose this is the mirror. Like this it is going to be placed. This is a concave mirror. Now how do we place the convex mirror? So remember one thing, this reflecting surface should always be towards the left only. You cannot simply draw like this. It's wrong. You will not get the right sign conventions. For sign convention, it is mandatory you draw in the correct position. And if you want to draw a convex mirror, now how do we draw a vex mirror? Convex. Just remove this mirror here and I'll place that mirror. Okay. Yeah. So this is how a convex mirror will be placed. Clear? That's all. Here only objects must be placed. Okay. Clear? Fine. Now let's come to the rules. This Cartesian plane is clear and we will move on to the rules. So let's see the. Now there are actually 7 rules mentioned. So let's see one by one by drawing them. Let's have let's have two mirrors drawn side to side, and then we will just discuss about both of them. Okay. So let me just divide the page. Now this is going to be a concave mirror. This is going to be a convex mirror, and this is a principal axis for both, right? Now let me just draw this a little back so that I'll get space for all the focus and all. Okay, yeah. Now here you will find the focus, here you will find the center of curvature for a convex mirror. This is a concave mirror. Yeah. So here you will find the focus, here you will find the center of curvature. That is clear? Yeah. Next. Okay, so how do we understand the rules? Let's understand them one by one. Here we have pole also. Don't forget the pole. Yes. Yeah. So first rule is pole is to be taken as the origin. So we have drawn that diagram, right? Y dash. So this is the origin. So pole has to be taken as origin. Okay. Pole is origin 0, 0. Okay. That is the first rule. Very clear and nothing new in that. Okay. Now, second one is important. All the distances are measured from pole. Just now I have explained, right? Focal length is also measured from pole. Radius, everything is measured from pole. Even object distance or image distance, whatever the distance it is, it has to be measured from pole only. Okay, that is the second rule. So what is second rule? All the distances must be measured from pole. Okay, that is the second rule, pole rule. Remember. Next, distances measured in the direction of incident ray are taken as positive. See, this rule is nothing but see. So now if you want to measure the focal length, suppose he will tell you focal length is 15 centimeters. Okay. See, object is obviously placed this side. That is the negative side. So you should be able to understand that this distance is negative. Okay. If it is the focal length given for concave mirror, it is going to be negative. Okay. But again, in the case of convex mirror, if he gives the focal length as 15 centimeters, it is going to be positive. Because from the pole, it is towards the right side. See, here focus is towards the left side. This will indicate that it is negative. So here the distances will be measured in negative. Nothing, very simple. See, here if it is towards the right, it is going to be positive. If it is towards the left, negative. That's all. Okay. So the distances, you should measure it in such a way. That is, you will be understanding it very clearly when we are doing problems on this. Okay. So now you may not understand, but you will understand while doing the problems. So this side, if you are measuring, it is going to be negative. If you are measuring towards the right, it is going to be positive. Again, here also negative and positive. So based on this only, you are going to put signs for focal length, image distance, object distance and all that. Okay. So you have seen the image distance, object distance, that from where you have to take that positive, negative, all. Okay. That is also completed. Now next rule we have, that is C. Object, suppose it is kept in this direction. So the heights above this, above the principal axis are measured as positive. Heights above the principal axis are measured as positive. And if the height is coming real and inverted, sometimes it will come, right? That time it is going to be negative. So the heights taken from the, if it is coming down, it is showing down of the pole or principal axis, you can say negative. It will have negative distance, height, negative height. Clear? So this is also clear, I am hoping. H to H and H dash also we have seen. For that also positive, negative, whatever it is, we have seen. Okay, that rule is also done, right? So majorly these are all the rules. So these are something you have to remember. Okay, that's it majorly. Now in the note points, he has given the picture, that's all. So I have showed you, right, how it is. So there is no need to see separately. Let's move on. Okay, now sometimes you will want to know, array, how to take focal length distance, if it is negative or positive for convex or concave. If you want to remember such things, no, I'll tell you one thing. See, for a concave mirror, this is the focus, center of curvature. So remember, for a concave mirror, focal length is always negative and radius of curvature is also always negative. Okay, object distance u is also always negative. Now v is also always negative, but in the last case you will be having a virtual and erect image. No, that case it is going to be positive. This is clear, no? For concave this is. So you have to, if you remember also, you can identify, or else you have to do the sign convention. If you, or else you just simply remember these or do the sign convention. Now for convex also I will tell you, just see that. Okay, for convex mirror also how focus and all, everything it is there, I will tell you. Okay, so no need to worry. Now this is a convex mirror, convex. This is the focus, this is the center of curvature. Okay, now for a convex mirror, focal length is always positive because it is towards the right, that's why. Radius of curvature also positive. Object distance, obviously it is going to be negative for both mirrors. Object distance is negative for both the mirrors. Now image distance, obviously in one case you will have at focus and other case it will be between the principal pole and focus, right? So obviously it is going to be negative. So here it is a short thing, like you can remember it. Okay, just keep this in mind. Sorry, positive, because it is in virtual one always. So V is positive. Okay, done. That's what I've told for concave as well as convex. Remember these, it will be helpful, or else do the sign convention by drawing the a picture how I have drawn, like that similar way. Okay, now what is U? Just recall it, recall all the things we have seen. Okay, what is U? It is object distance. Just have a glance over this because we are going to see one nice relation between all this. So V is image distance, F is focal length, R is radius of curvature. Okay, now again in this you can include H and H dash also. H is object height, H dash is image height. Okay, H dash, that's all. Recalled? Clear? Now let's move on to the mirror formula. Okay, so mirror formula is something which is very important. We are having a lot of applications for this, lot of questions will be asked, so be very careful. Now first we will discuss the formula directly. So for this formula you will need U, V, F, R. See, F or R, that is a choice again. Okay, either F or R. I'll tell you the relations first, see that. Okay, so what is the mirror formula? 1 by U plus 1 by V is equal to 1 by F. Hear it out carefully. 1 by U plus 1 by V is equal to 1 by F. So you all know what is V, U and F. See, in the previous slide just now we have seen. So V, U, F. Object distance, image distance and focal length. So that's why I have written here so that you will recall it. So that's what. Now you can write this in other way also. Now we all know that focus is nothing but half of radius of curvature. So you can say R by 2. See, now I'll draw one mirror and show you. This is the focus, this is the center of curvature. So this is focus, right? So focus is half of the radius of curvature. This is radius of curvature. Focal length is half of it. Okay, R by 2, that's why I have written. Now I'll substitute this instead of F. Okay, so 1 by U plus 1 by V equal to 1 by R by 2. Now 1 divided by R by 2 is nothing but 1 into 2 by R. So just write 2 by R instead of that. Okay, so 1 by U plus 1 by V equal to 2 by R. This is the first formula, this is the second formula. These are the mirror formulas. That's all. Okay, derivations and all is given, that is not at all necessary. Because in 10th class also you will not have your derivation, you know. In 10th class also you will not have derivation. No need to learn. Okay, just remember the formula, enough. So this optics is actually very much useful for 10th class. You will have one chapter itself, you know. You'll have a chapter called light reflection, refraction. In that chapter, all these topics in one complete chapter, it is piled up. Okay, so learn this chapter nicely. It will be beneficial for your board examinations. Okay, yeah. So let's move on to the next part, that is magnification. Okay, So magnification is nothing but it is the ratio of height of image to the height of object. So h is to h dash. See, I have showed you what is h and h dash. H is object height, h dash is image height. So magnification is the ratio of h and h dash. You understood this? That is only the formula, that's all. So m is equal to h upon h dash. H dash upon h. See, the ratio of height of image is to ratio of height of object. So ulta. Okay. Yeah. So that is the thing. First formula. And you have one more formula that includes u and v. Okay. Image height and object height. By using that also you can be able to find the magnification. That is minus v by u. Okay. This is one more formula. That is clear. These are the two formulae for finding the magnification of spherical mirrors. Okay, clear? Fine. Next we have a few note points. We will see that and just end video. Okay. Now, if the magnification is positive, so let me write it one by one. If the magnification is positive, then the image is virtual and erect. Okay, image is virtual and erect. See, how do you get to know all this? See, positive means this side only, no? Positive means towards the right. Right side, it is behind the mirror means obviously it is going to be a virtual one. So, by seeing the sign also, you can just identify it. Now, second rule. If M is negative, then the object, then the image is real and inverted. Okay, real images only are formed in front of the mirror, right? See here, if it is image is forming, it is obviously a real one and it will form inverted images. Clear? Okay. Now, if the magnification is greater than 1, that means image is bigger than object. Image V is greater than U. Sorry, image is greater, no? So, H dash is greater than H. Image height will be bigger than the object. Fourth rule. If the magnification is less than 1, if it is less than 1, the image height is smaller than the object height. Okay. Next. Fifth rule. If magnification is equal to 1, then both the height of the image as well as height of the object is same. Okay. Next. I told you, right, magnification can be written as image distance by object, that is minus v by u. So, okay, that there is a error in the textbook. Okay, it is going to be negative. Error is there actually. If you want to find simply image distance by object distance is wrong. It is minus v by u. Up also it is written, but down they wrote mistake. Down, up it is correct. Okay, so these are the note points. So do like, share and subscribe to Vishwablooms. Thanks for watching our video. Bye bye. See you all in the next video.